First.
This is Susan.
Hey guys, we're going to talk about the most important lesson for the entire year. This is one thing that you are not going to stop doing. You've got to be able to write formulas for the rest of the year. So we're going to go through all the different types of naming compounds. For my honors kids, this is following up on the inquiry stuff that y'all did the first day. So when you have an ionic compound, you have two things that are charged. When you're looking at the name, if you see prefixes, it's not an ionic compound, and we'll talk about that in a minute. You have a metal and a non-metal, or you have some polyatomic ions. So when you are writing the formulas correctly, you write the different symbols. So we have sodium is a +1 charge, chlorine is a 1- charge. They cancel each other out, so the formula is going to be NaCl. Sorry about my writing. Magnesium, when you look at the periodic table, magnesium is a 2+ charge. Chlorine is a 1- charge. So this is where we get to this last rule that we have over here, where it says cross and draw. The easiest way to figure out how you're going to write the formula correctly is you forget about the positive and negative charge and just look at the numbers, and you see that for every 1 magnesium, you need 2 chlorines. Calcium nitrate. Calcium is a 2+, based on where it is on the periodic table. Nitrate, we have that H, that means we're dealing with a polyatomic ion. So you have NO3. When we look at that up, that's a 1-. Now the NO3 is a whole thing. You're not going to take the A off the calcium, so you're not going to take the little 3 off. Crossing again. And so you have Ca, parentheses, NO3, close parentheses, 2. And the last one is where we have this Roman numeral. That Roman numeral tells us the charge of the copper. It can be a 1 or a 2, so we will always tell you. Phosphate, when we look that up, is a PO4 and a 3-. That's the whole thing. We're not moving that 4 anywhere. Cross them over, and so you should get copper. We need 3 of those. Man, my handwriting's bad this time around. With a 2-. So that's writing the formulas. Look at the charges, look them up. We haven't asked you to memorize anything yet, so use what you're provided.
Alright, covalent compounds. All we're going to look at are the prefixes. The prefixes are going to tell you exactly how many you have. You have to memorize these prefixes. And they go in order. So you start mono is 1, di is 2, tri is 3, tetra is 4, penta is 5, hexa is 6, hepta is 7, octa is 8, nona is 9, deca is 10. You have to memorize these. If you don't memorize them, you won't have a clue what you're doing. So the first one says nitrogen trifluoride. Now if you notice, nitrogen does not have a prefix. We never write mono on the first element. So the first one is nitrogen, and it just has 1. And then it says trifluoride, so tri is 3, so we have 3 fluorines. The number one mistake, people are going to cross these. The prefix goes with whatever element it is. The next one is carbon dioxide, so we have 1 carbon, and then we have 2 oxygens, dioxide. Diarsenic trioxide, so di means 2, so we have 2 arsenics. AS, yeah. Trioxide, so 3 oxygens. And carbon monoxide, carbon doesn't have a prefix, so it's 1. Mono, see we do use mono on the second element, so it has 1, so it's CO. And then carbon tetrachloride, so we have carbon 1, and then tetra is 4, so we have 4 chlorines.
Okay, so on the next one, we're going to actually go from the formula to the name first, and then we'll go from name to formula for the acids. Acids are your last thing. You know you have an acid when you have hydrogen listed first. With anything else, it can be a single element or it can be a polyatomic ion. The rules are if you have no oxygen, then it has hydro at the beginning, then you use the root of whatever it's bonding to, and then we end in ic acid. So this first example, H3P, we have no oxygen, so it's hydro. The P is phosphorus, so we say phosphor is our root. And we end in ic and acid. Okay, the next one, HCN, we still have no hydrogen, so we still have hydro. But we're going to have to look up what CN is on our polyatomic ion list, and that's cyanide. So we change that ending to ic, so ionic acid. The last two examples are when we do have oxygen in them, so we don't have any hydro. But we're going to change our polyatomic ion name. If it ends in ate, it becomes an ic acid. If it ends in ite, it becomes OUS acid. One of the ways I tell everyone is the ate always has one more oxygen than the ite, so it ate the extra oxygen and now feels ic. So acetate is our C2H3O2, so we're going to change that ate to ic, and so we have acetic acid. And then when you look up SeO3, that is selenite. So the ite becomes us, so you have selenous acid.
All right, now that we know how to write the names, we're going to write the formulas. Same things you need to know. We have to look at it. Does it have hydro in it? And does the ate change to ic? So we need the first example here says hydrosulfuric acid. Remember before, if it has hydro, it has no oxygen. It's just the element from the periodic table. So we know it starts with H because it's an acid. Hydrogen's +1. Sulfur is look on the periodic table is -2. And then we're going to cross and drop them just like ionic ones. So this 2 is going to come down. So we have H2S. For the third one, there's not a hydro on the front, so it means I got oxygen in there somewhere. It says sulfuric. Ic changes to 8, so I need to look up sulfates on my polyatomic ion list.
Oops. Sorry.
Hydrogen's +1. Sulfate is on the back, the SO4, and it has a 2-. They're going to cross and drop. So we're going to H2SO4. The next one is sulfur us changes to ite. So I need to look up sulfite, SO3. It also has a 2-, so they cross and drop. So we get H2SO3.
Okay, the next thing, we're going to go from the formula itself to the name. On your ionic compounds, the metals don't change their name, they just use their name. If it's an element at the end, it's going to change the ending to "ide." In polyatomic ions, we don't change the name at all. So we have K2O, so K is potassium, and O is oxygen, so we say oxide. The charges on the periodic table tell us how many we have in the formula, so you don't have to specify any of that. NH4, when we look that up, is ammonium. And then S is sulfur, so we change that ending to ide. So we have sulfide. The next one, Mg, is magnesium. Make sure you're paying attention to what you're writing, magnesium. A lot of people confuse it with manganese. There are two different elements. We have to look up the NO3 on the back, and the NO3 is nitrate, so we just write nitrate. We have NH4 again, so that is ammonium. And then PO4 is phosphate. So you can see that you can have two polyatomic ions together, just like you can have just two metals. And the last one is chromium, and we have oxygen. Now this is where it gets a little tricky because you have to figure out what the Roman numeral is, because chromium is in the middle. Just like we cross and dropped to figure out how many of each we need, we can also uncross to figure out what our charges were. So when we uncross, we see that chromium had to be a 3+. And then oxide.
Alright, last one is covalent. These are super easy as long as you have memorized those prefixes. So the first one we have B2H6. So 2 means di, so I have di, And then B is bromine.
Boron.
Boron. Oh my god, I don't have periodic table in front of me. 6 is hexa. People get hexa and hepta mixed up. Hexa has an X in it, just like the word. 6 has an X in it. So maybe you can keep those straight. And then hydrogen will be hydride. So they're going to end in IDE. Carbon is the first one, but it has one of them, so we don't use mono on the first one, so you have carbon. 4 is tetra. Now we got bromine, but we're going to change it to bromide on the end. Cl is chlorine. There's just one, so we're going to use just chlorine. There's one fluorine, but we're going to write monofluoride.
Okay, so that's all your names to formulas, formulas to names. The majority of what you're going to do this entire school year until the end of May is going from the name to the formula. So this part of this unit is the most important part to make sure that you get that foundation. If you have questions, attend tutoring.